Alright, today we're going to start talking about the shortcuts. We are eventually going to talk about 5 shortcuts to prove that 2 triangles are congruent. We're just going to do 2 of them today. We're going to look at the first 2. If I can show that all 3 pairs of sides of 2 different triangles are congruent, I can say the triangles are congruent. I don't need to say anything about the angles. Okay, so if I can prove that these 2 are congruent, these 2 are congruent, these 2 are congruent, that's enough. I can then claim that the 2 triangles are congruent. Where?
I don't know. I literally can see it.
In your brain? You see it in your brain, but
Having
your
some
brain is
deja vu.
behind your eyes.
Actually, no, we like this little thing. Like side angle,
Yeah, but
side
it's the behind your eyes.
side angle.
What about them?
I don't know.
It doesn't have to, I didn't say right behind your eyes, just behind them. The wall's behind my eyes right now. It's not right behind my eyes.
Alright, the next one, okay, if I can show the 2 sides and the angle between them, okay, that's what it means by included angle. Okay, it has to be the angle between them. It cannot be an angle outside of them. So, for example, if I can show this pair of sides, this pair of angles, and then this pair of sides, okay, it could not be these 2 sides and then these 2 angles. Okay? It cannot be an angle that's not between the 2 sides we're showing congruence.
Like, why can't we do that in other angles?
So, it could not be those 2 angles.
Why not?
For us to use side angle side, okay, it has to be the angle that's in between the 2 sides.
Oh, I see.
Okay?
I think in between the 2
No. The angle that's between the 2 congruent sides. Okay? It has to be the angle that's between the 2 congruent sides. If we were only able to show one angle and then 2 other sides where the angle is not between the 2 sides, we could actually create multiple triangles with those pieces of information.
We're a Jesus figure.
We're like knowing everything.
Okay. So, these are the ones we're going to look at in detail today, but I'll mention these ones here first. So the next way we're going to use is angle, side, angle. And again, this is where we're saying 2 angles and a side that's between them. So for example, we could say these 2 angles, these 2 sides, and then these 2 angles. Okay, where we're saying the side is between the 2 angles.
3 of something. 3 of stuff as long as it works together.
Yeah.
So would it work with the other side though? That wouldn't work with it.
Well, so that's the next one. Angle, angle, side. It will work. If we have any 2 angles and a side not between, that will work. So we could say.
So they all be between each other for all.
So no. So this one, this is the one where it doesn't have to be between. We can say 2 angles and a side not in between. Okay. The only one that doesn't work is 2 sides and an angle not between them. Okay. That does not work. The rest of them will work. Side, 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 angle, side, angle, side, angle, and angle, angle, side.
Okay, so the only one that won't work with the thing is angle, side, side.
Right.
Okay.
Now the last one that we'll look at a little bit later is specific to right triangles. Right? This one is saying if I can show that if I can show the 2 hypotenuse are congruent, and then any other pair of legs.
I like hypotenuse.
Okay? If I can show the 2 hypotenuse and then either pair of legs are congruent in a right triangle. Okay, so this is essentially the only time that angle side side would work if we have a right triangle.
Because we have 2 angles, right?
We only have one angle actually. We have one angle and then 2 sides.
Okay, so why would that work and not the other one?
Well, the easiest way to explain it is Pythagorean theorem.
Because you can move
Yeah, we did do
If we know these are right triangles and I know two sides are the same, then by the Pythagorean theorem, the third pair of sides would have to be the same. Then we have side, side, side.
We like
that.
graph
No,
for a squared plus b squared c squared.
Go ahead and come up
A
with one.
squared, yeah.
we learned that.
B squared, yeah.
Yeah, I think Pythagorean theorem is something you have seen before. Okay, now this bottom section on the left side here, it just lists a lot of possible reasons that we could have sides or angles congruent to each other. These are all things that we've already talked about, and this list isn't all inclusive, all encompassing, but it does give most of the possible reasons that we'll encounter. Okay, there could be a few more that will be a little more rare, but this gives us most of the ones that we'll see. Right, so, and we talked about this idea a little bit yesterday as well. Okay, if we know that two triangles are congruent, then we know their corresponding parts are congruent. So if I know that these two triangles are congruent, right, I don't even need a picture, right? I can just look at the statement and say, well, I know that AB will be congruent to DE. I know BC will be congruent to EF. And then for the sides, I could say AC and DF would be congruent. And then for the angles, we say angle A and angle D are congruent. Angle B and angle E are congruent. And angle C and angle F are congruent. Okay, so that's what we talked about yesterday, right? Using a statement to figure out which pieces correspond and therefore which pieces are congruent. Right? Questions? It's what?
But you haven't smiled.
Yeah, so that makes it all better, right? It's given. All right, so let's take a look at using some of these shortcuts in a proof now.
Each shortcut's in class.
All right. We could what?
You made a shortcut in class and you can't do it.
We barely even have
I think we've got almost 20 minutes.
Exactly.
Exactly.
Steve,
It's
you
less
did a
life when you wrote angle side before you wrote.
Yes, I did.
Okay.
I did that on purpose. Because I could have written it as side, side, angle, but I chose to rate it as angle, side, side.
This is bad. After when we're doing this,
Oh yeah, why didn't you put SSA?
Because I'm immature.
All boys are
hey. Mature people are happy people.
No, they're called immature.
No, we're happy. Just
Imbecile.
just trying to.
Ouch.
I think we all mature. Probably grown. It's not fun. It's not fun.
All right, so on the back, or I guess it's not the back for you, it's on the right side of your paper. For side, 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 if I can show that all three pairs of corresponding sides are congruent. So in this example, right, we would say, if I can show that AB is congruent to DE and BC is congruent to EF and AC is congruent to DF, then I can claim the triangles are congruent. Right? So again, we talked about writing a congruent statement yesterday too. There's multiple ways I could write a congruent statement for the triangles. It's making sure that I'm matching up corresponding pieces. So I could say triangle ABC is congruent to triangle DEF. Or I could say triangle CBA is congruent to triangle FED. Right? Just as long as I'm matching up corresponding pieces in my statement. So let's look at a couple proof examples. So in this first one, I'm given a lot. I'm given that PQ and ST are congruent. So let's mark that on the diagram. Okay, and so I can fill in the first line is given. Then I'm given that QR and RT are congruent. So QR, RT, that's given. And then I'm given that R is the midpoint of PS. Now, that doesn't directly tell me about anything on the diagram. Okay, but then they claim that PR has to be congruent to RS. If I know R is the midpoint, why?
Reflected. It's definition of midpoint.
Definition of midpoint. Okay? If I know that R is the midpoint of PS, then I can claim that these two halves of that segment are congruent by the definition of midpoint. So now that I've shown that all three pairs of sides are congruent, now I can claim the triangles are congruent by
That's CPTC.
Oh, yes.
side, side, side.
Okay, sure, okay. I see. We don't really have to look beside India.
We okay with that?
Probably, yeah.
Okay, if I can show all three pairs of sides congruent, then I can claim the triangles are congruent by side, side, side. Do you need to go talk to somebody?
Not get me started.
All right. So why don't you? Do we want to do another one together, or
Yes.
yes?
No,
Why
no.
is that your face? It is
No,
that.
I want to say.
You said definition when it says standard
With a
SSS.
frame.
All right. Why don't you guys try number 2 here? Okay, and I'll write it on the board as you're trying it, and then compare our answers here.
Are you serious? My grandpa's
I'll take a look here in a little
bit.
bit. All right. Did we get given, definite midpoint, side, side, side?
I got that.
Yeah.
But
Questions so far?
What are the answers back?
All right. So let's flip over to number 3 here. On this one, we have to write the entire proof. Okay. We're not given the statements or the reasons here.
Can we just say because?
No.
The statement is it's congruent because. Reason because.
So I've got 2 givens. Right. Those are easy. Okay. AC is congruent to AD. Given, and let's mark that on the diagram. I'm given CB and BD congruent. So let's mark that on the diagram. But I'm not given anything else. What else can I do here?
We could bisector.
We're not given anything about a bisector. Okay?
maybe it's congruent to AD. Either.
Right. We can always say that something is congruent to itself by the reflexive property. Okay, this one is going to creep up a lot as we go through triangle proofs. Whenever something is overlapping. Say it again.
Two sides.
Yeah. So now,
Are we not using the CPCCC?
so no, that one was only if we were showing all 6 parts congruent. So now if we're using one of the shortcuts, we're going to say
Side.
side, side, yeah. So now we can say triangle ABC is congruent to triangle ABD by side, side. Sassy. This is called your name. Just call you Sass from now on.
Wouldn't that be cheap on a test though? Say out loud.
Any questions on side?
Does the angle have to go in the middle?
Yes.
Side.
Yes. So let's take a look at side angle side then. Okay, on this one, remember we said in order for this to work, we have to show that 2 sides are congruent and then the angle that's between them is congruent. So in this example, we're saying AB is congruent to DE, then angle B is congruent to angle E, and then BC is congruent to EF. Then I can claim the 2 triangles are congruent. Triangle ABC, triangle DEF. Okay, so let's take a look at a few example proofs for side angle side. Alright, so on the first couple examples, we're given the statements. So I'm given that JM and NL, so these 2 sides, are congruent. Then I'm given angle JMN. So JMN is this angle here, is congruent to LNM, this angle right here. Well, then they claim MN is congruent to MN. That's the reflexive property, because that's the same thing. So now, I've got 2 pairs of sides, and the angle that is in between them. I claim these triangles are congruent by side angle side. Alright, you okay with that one? So let's see. Yeah, why don't we take a couple of minutes and you guys try a couple of these here. Okay, I mean, these all should end up being side angle side. And see if you can fill in the reasons here.
How is what is BD and BD though?
What is what?
Reflexive.
Yeah,
Did you put definition of midpoint twice in 6?
Yeah, I did.
Okay, it doesn't help.
I didn't use it for 3 though. I thought it was-
What'd you put for 4?
Okay, definition.
Again.
What?
Again.
No, I only used it twice.
What'd you put for 2 then?
For 2, I used definition.
What'd you put for 3?
Vertical.
8.
The alternate.
All right. Take a look up here at here's 5 and 6. Okay. One of the different ones on number 5 was the third line, showing that those two angles were congruent by definition of a bisector.
We have someone going crazy. Like, takes it. Like, can you get that?
Then on number 6, okay, we had to use vertical angles. Okay, this is another one that's going to creep up a lot. Okay, vertical angles. Okay, be okay with this one? Now, I'm not sure if we got all the way through 7. Okay, but I did want to talk about one thing on number 7 here. If I'm given parallel lines should automatically tell us we're going to use something like alternate interior or alternate exterior corresponding, something like that. So in this case, we're given that these lines are parallel. Therefore, I can claim that these two angles are congruent because they're alternate interior angles. Okay? Questions on